Next, I'd like to please invite J.T. Grumski to join us with his opening comments. J.T. is the Business Unit General Manager of Energy, Environment, and Infrastructure Business Unit in SAIC. Over the last 5 years, J.T. has been the leader in the company that has transformed the company from being an energy consulting company to a full-service energy services company, meaning he's taken it from a company that provides consulting all the way to commissioning of an energy project. So with that, let me please invite J.T. and please join me in welcoming him.
Like many of you, I have an engineering background, and we're trained to solve problems and implement solutions. One of the many tough problems we face as a nation is finding a way to economically upgrade our energy infrastructure while making it cleaner and more reliable. And, you know, we face some technical challenges, but none of them are showstoppers. However, the lack of political and economic alignment are real barriers. I'd like to address 3 key points associated with stepping up capital investment, with aligning utility incentives, and with shifting economic resources. We have a real history of taking on challenges and being successful. You know, during the first half of the 19th century and the 20th century, we built the strongest industrialized nation in the world, and that was enabled by a nearly 100% domestic energy system. The primary enabler for that energy system and the associated infrastructure was capital investment. And investment is made in our infrastructure because it was viewed as it was material, it had an attractive return at a relatively low risk. We can't continue to live off the investments of previous generations and expect to maintain our economic well-being. Our challenge is to take a much more integrated view of the energy system and to implement an economically affordable solution. And what this requires is a view that kind of aligns policy and incentives in a manner that will drive that innovation and capital investment, and it will modernize and create a U.S. energy system that will serve us into the 21st century. So the first point is that it's not just good enough to maintain current investment levels. We require a significant step up in capital investment to maintain that energy reliability and support that economic growth that we need. Why? Well, because a large portion of our energy infrastructure is 50 to 70 years old, and the original capital investment is largely amortized, and therefore the utility rates are artificially low. The 600-plus coal-fired plants in the U.S. have an average age of 40 years. The 104 nuclear plants an average age of 30 years. The American Association of Civil Engineers has given our electrical energy infrastructure a D-plus grade and projected that the investment needs could be as much as $1.5 trillion by 2030. And with the addition of about 10.5 gigawatts in 2009 alone of renewable energy, and a lot more to come in the future as a result of government incentives, the reliable, high-quality power delivery has become more challenging. The intermittent nature of solar and wind represent a significant system challenge to maintain reliable supply when these resources are unavailable. When failure of the power system occurs, it comes at a high cost. The total cost from the famous blackout that occurred in 2003 was estimated to be between $4 and $10 billion for both the U.S. and Canada. The Electric Power Research Institute estimates that power outages and insufficient power quality cost the U.S. economy over $119 billion per year. So determining a way that we can replace these aging assets and avoid failures will not only result in overall cost savings, but it'll help us advance the smart grid implementation and a more efficient and cleaner energy mix. We have, of course, the responsibility to be smart on how this increased investment is spent to ensure that we meet our goals. A second key point is aligning the incentives that utilities have, and especially aligning them around the investment in energy efficiency and demand response programs. The North American electricity system has been referred to as the world's largest and most complex system of power generation and transmission and distribution. Investments in the U.S. electricity system have been driven by clear financial incentive to prefer investments in supply-side assets, since these investments, under today's rules, contribute to enhanced shareholder value. It's projected that between $1.5 and $2 trillion will be required in new generation over the next 20 years. However, energy efficiency investments and demand response programs can reduce that required investment in generation by up to 50%. So providing financial incentives to utilities, if it performs well in delivering energy efficiency and demand response programs, requires a change in that utility rate basis and business model by allowing for an attractive financial return on efficiency and DR investments. Improving energy efficiency in our homes, businesses, schools, governments, industries will collectively consume more than 70% of the natural gas and electricity used in this country. It's one of the most cost-effective ways to address the challenges that we have with high energy prices, with energy security, and global climate change. Consider that 30% of all the energy in U.S. buildings is used inefficiently or unnecessarily, and that nearly half of all the U.S. greenhouse gas emissions are generated by commercial buildings and industrial facilities. In 2009, a McKinsey report titled Unlocking Energy Efficiency in the U.S. Economy stated if energy efficiency were implemented holistically throughout the U.S. economy through 2020, it would yield a gross energy savings worth more than $1.2 trillion. And that's more than twice the $520 billion in upfront energy efficiency investment that's needed in that time frame. EPRI estimates that the combination of demand response and energy efficiency programs has the potential to reduce non-coincident summer peak demand by 157 to 218 gigawatts. So utilities need to have the opportunity to profit from energy efficiency and demand response that is intended to substitute for this capital investment. So where do we find these additional resources for investing and upgrading domestic energy infrastructure? One material option is to shift to the economic resources associated with purchasing foreign oil and shift that to the domestic energy infrastructure. In the mid-1950s, the U.S. began importing energy, primarily oil, and that trend has implications which not only jeopardize our energy infrastructure, but our economy and national security as well. While much has been published about the concerns related to imported oil, not many Americans grasp the broader impacts, because if as a nation we did, we may find that an economic clean energy solution is really achievable. Let's review some of the facts and the broader impacts. The U.S. consumes 1/5 of the world's energy annually, and we spend over $1 million every minute and more than $1 trillion annually. Of that trillion, approximately $400 billion is spent on foreign oil. But the real economic impact annually to the U.S. from that imported oil has been estimated by the National Defense Council Foundation at over $825 million, which is on par with the American Recovery and Reinvestment Act funding on an ongoing annual basis. This estimate includes losses from direct employment, increased national defense costs, disruption losses, reduced tax collection, and loss of U.S. energy investment, which is by itself estimated at $400 million. When you look at the environmental impact of the oil use, remember that about 75% of that oil goes to the transportation sector, and this sector is responsible for about 28% of the U.S. greenhouse gas emissions. So there are a number of solutions that could substantially reduce our imports of oil, including biofuels, hybrid plug-in vehicles, to name a few. But in interesting studies show that even if you assume all the electricity to charge an electric vehicle fleet comes from additional fossil generation, there are less greenhouse gas emissions associated with powering electric vehicles than gasoline-powered vehicles. Additionally, there are several studies that project that a substantial portion of electric cars in the U.S. could be charged from the existing generation capacity that we have today if we had a smart grid and we charged during non-peak hours. The U.S. military is the largest purchaser of oil in the world, and the Department of Defense is the largest oil-consuming government body in the U.S. and the world. The DoD clearly gets it when it comes to energy and is working hard across all its branches to reduce both fuel and electricity usage. Shifting our transportation sector back to domestic fuels, such as electricity, requires an investment, especially in the grid. The good news in all this is that there is a substantial payback and an environmental benefit in shifting investment from foreign oil to domestic energy sources and infrastructure associated with transportation. But to accomplish these essential ambitious goals, we have to take an integrated view of our energy system and align that policy and those incentives. We need to step up the capital investment to maintain the reliability and support the economic growth. We've got to align utility incentives with investment in energy efficiency and demand response programs, and we've got to shift that economic resource associated with purchasing foreign oil to a domestic energy infrastructure investment. If we're able to do that, we will drive the innovation and capital investment that is required to modernize the U.S. energy system, and it will serve us well into the 21st century. SAC is stepping up our commitment, and we're making investments to ensure that we can deliver those solutions that are going to be required. And we're supporting all our customers in taking on these significant challenges. I'd like to thank all of you who have come to this conference and want to contribute to our country's energy future. Thank you.